Hey guys, Rock Papa here. Hope you guys are doing fantastic wherever you are. Today we're just going to look at some rocks and see if we can identify them. So let's go. And I'm picking these rocks up from my rock piles. I've got two of them right here by the minimalist cottage. And looks like this will be our first rock. Okay, nice little rock. Been polished. What minerals do you see in this rock? I see some gray ones. What are we going to call those? Let's call them quartz. Quartz is always gray or clear in a rock. I see a lot of pink color. What could pink be? Well, we know that potassium feldspar often is pink. I see a little bit of black stuff here and here. Let's turn it like this. Yeah, it's a good view right there. There's a little bit of black in there, but mostly what we have is quartz and potassium feldspar. So what do you think this is? You're right. This is granite. This is polished granite from a rock quarry. And granite is a felsic intrusive igneous rock. It's emplaced during crashing events deep within the earth, and millions of years of erosion expose it on the surface. So our first rock is granite. Here's our next rock. The thing I noticed about this rock is it's got lots of minerals with big crystals, and some of the crystals are blue. Some of the mineral crystals are blue. Bluish. It's also got whitish mineral crystals in it, and some dark stuff here. I don't know what that is. So, is it an igneous rock? Do you think it's felsic for sure? So, what are the felsic rocks that we know about? Well, igneous felsic rocks are granite, felsic tuff, felsic metatuff, and also granite gneiss. It looks like granite, but in fact, it has the minerals that are in granite. This blue stuff is actually quartz, blue quartz. The white stuff is feldspar, maybe potassium, but probably sodium, a lot of sodium feldspar in here. The dark stuff is probably biotite, or that could be funky looking quartz. This, in fact, looks like granite, but it's granite gneiss, and the blue quartz crystals tell me it's granite gneiss. Blue quartz is a sign that the rock that we're looking at has had a lot of metamorphism applied to it. There are minerals, zircon I think is one of them, that are not affected greatly by metamorphism, and those minerals get concentrated and give a blue cast to the quartz in the rock. There's some feldspar hunks there. So this is granite gneiss with blue quartz in it. And this is actually the Corbin granite gneiss. They call it the Corbin granite gneiss. It's the old rag granite gneiss that you find in Virginia along Shenandoah National Park and elsewhere. And it is ancient Precambrian basement rock that was exposed as Rodinia rifted apart. So we're talking about the rifting of Rodinia, and the first thing that happened in the eastern United States was a big rift basin opened up, just like the rift basins that we find in East Africa, which is rifting apart. And sediments filled that rift basin. Then another rift basin formed with a hunk of granite gneiss in the middle of horst. And this material was part of that horst. So this is from the Western Blue Ridge Province, which is Rodinia Rift Basin material plus Rodinia volcanic material like the Catoctin Greenstone in Virginia and the Mount Rogers rhyolite in Virginia. So yeah, and the blue quartz is a giveaway. You can find this rock, I think, in Red Top Mountain State Park in Georgia. Okay. Hey guys, didn't I just say earlier that quartz is always clear or gray in a rock? Well, this case where there's blue quartz is a rare exception to that. So you find blue quartz in this center horst rock, Corbin gneiss, Orag granite, up further north. And another place where you find it is in the turbidite sandstone, which is a Rodinia Rift deposit. It's material that washed into the Rodinia Rift basins. And you find this stuff at Great Smoky Mountains National Park. You find turbidite sandstone with the blue quartz. And that blue quartz very likely came from this very same high spot or horst that we just looked at. Here is our next rock. This rock came from Tignall, Georgia, which is from the old home place of my family, the Shepherd family. And this rock was one of the rocks that was used to make the chimney on the old Shepherd house. So let's see what kind of minerals we see here. I see a lot of white stuff. And I see some reddish speckles, brownish speckles. So, get away, Skeeter. So I'm asking myself, is this granite? No, it's not granite because it doesn't have, I don't see any quartz here. There might be some, but it doesn't have a lot of quartz. It doesn't have any biotite that I can see. Okay, is it sandstone or quartzite, which is metamorphic sandstone? No, because this white stuff does not look like quartz. And sandstone and quartzite are made of quartz. Okay, so the presence of these little dark dots in between the white stuff lets me know we have both felsic material here, the white stuff, which is probably feldspar, and we have iron-rich material, darks with dark spots. So the only other thing I can call this is Felsic metatuff. And as a matter of fact, that's what it is. It's Felsic metatuff. That's tough. That's felsic material, mostly feldspar, that was blown out of a volcano that was part of a volcanic island chain back during the Akkadian orogeny. And this came from the Carolina terrain, which is located southeast of, in Georgia. It's located southeast of Athens, Georgia. Where did it come from? Well, about 370 million years ago, the Akkadian microcontinent crashed into North America, way up north in New York, Pennsylvania, Maine, that sort of area. It eroded, all its mountains were eroded into the Catskill Delta, which is also located up there. Then it slid southwest along the Brevard Fault Zone to where it is now, off Georgia and Carolina. So, felsic tuff. Okay, here's one. Most people recognize this. It's dark, so that means it's a mafic rock. It's got light spots in it. So it's a mafic rock overall. So if it's a mafic rock, it could be gabbro, could be diabase. Those are intrusive mafic rocks. It could be basalt, lava, or it could be a metamorphic version of any of those, which we would call amphibolite. You probably know that this is basalt lava. One giveaway is all these pock marks, these openings. Those were gas bubbles in the lava as it cooled. So what is the white stuff? The white stuff is called caliche, I believe it is called, and it is calcium-rich material that is leached out from the calcium-rich feldspar that's in the rock. And if you drip acid on these white spots, they will fizz because it's calcium-rich material. This came from the Snake River Plain in Idaho. And basalt can look a lot of different ways. But at the Snake River Plain, this is just one of those ways it can look. So we have basalt lava. Next rock. Super thin. It's pretty hard. Thumbnail can't scratch it. It's got ironish stuff in it. So that tells me this is a sedimentary or metamorphic rock. It's a sedimentary rock or a metasedimentary rock. Sedimentary rock, it would be shale. But shale, you can usually scratch it with your thumbnail. Not always. A piece of Cambrian shale, Conosaga, and see, I can scratch that. So it's harder than shale. So if it's harder than shale, it must be metamorphosed, and that would make it slate, and that's what it is. And it's got iron in it. So this is slate. This is Anakeesta slate from the Western Blue Ridge province, and it's iron and sulfide rich. It's the kind of stuff that you find in the Great Smoky Mountains National Park. If you've ever been to hike the Chimneys or the Alum Cave Bluff Trail, you're walking in all kinds of this Anakeesta slate. And it was dumped into a rift basin. It was material that was dumped into a rift basin as Rodinia supercontinent was rifting apart. And this very fine, very dark mud came into the basin and settled down in these low oxygen pockets amongst the other graywacke and metagraywacke, and eventually turned into slate, Anakeesta slate. Here's our next rock. I noticed about this rock that it has a kind of a greenish color. That's the main thing that I noticed. And as I recall, ultramafic rocks are greenish in color. Ultramafic rocks are rocks that are located at the very top of the mantle originally, and they get shoved up on the land when ocean crust is shoved up during when two continents collide. So if this is an ultramafic rock and it's green, I'm thinking it's going to be something like serpentinite, which is a metamorphic version of dunite or peridotite, which is the main rock in the mantle. If it is serpentinite, it'll be soft enough for me to scratch with my thumb nail. And look at that. Yep. So if I see a greenish rock that's soft, I'm going to call that an ultramafic rock called serpentinite. Serpentinite is the state rock of California. Okay, here's a monster of a rock. This rock came from near where my sister lives in Clarksville, Tennessee. And that would be part of the Nashville Basin, or one of the highland rims that surround the Nashville Basin. Clarksville is just a little bit northwest of Nashville, Tennessee. So what is it? Well, I know in that area you have a lot of sedimentary rocks. That's the area of sedimentary rocks. The Valley and Ridge Province to the east of Nashville has a lot of sedimentary rocks, like limestone. And so does and those layers go all the way underneath the highland rims. So, is it limestone? Is it limestone? If it's limestone, it doesn't look like limestone. But if it's limestone, this knife ought to be able to scratch deep grooves in it. And it's not. Also, if it's limestone, it should fizz in HCl, 7% HCl solution. And it doesn't. It doesn't. This knife does not really scratch it, so it's hard stuff. Those scratch marks are really the metal from the knife on this stuff. So it's hard. It's not quartz, though. It's not quartz vein rock, because it just doesn't look like quartz vein rock. And as a matter of fact, it is Chert. It's part of the either the Fort Payne Chert Formation, or it could also be part of the limestone formations that go out into the Nashville and Clarksville area and the Highland Rims that has been silicified. In other words, water-containing silicon has gotten into the limestone and made a lot of chert deposits. So that's what it is. It's bedded chert, possibly the Fort Payne Chert Formation or something like that. Next, here is a dark rock, mafic rock. Light spots in it. It's got a brownish iron coating on the outside. So we know this rock has a lot of iron. It's really heavy and very crystalline. It's hard to break this rock. Here might be a good look at it. And the white spots, some of the white spots look linear and drawn out, kind of lath shapes. So, is it basalt? No, it doesn't look like basalt lava to me at all. Is it gabbro, which is a mafic intrusive igneous rock? It's not gabbro, because if it were gabbro, it'd look something like this. It'd have big crystals of both dark, which would be, hornblende and pyroxene, and light, which would be calcium-rich feldspar. So it's not that. It's not. It might be amphibolite, but I don't see any kind of. Metamorphic band. I don't see any kind of metamorphic banding here, and I don't see layers. Foliation like you would find in some amphibolite. Okay, so the only other possibility that I can think of is Diabase. Diabase is an igneous rock that we find all over the eastern United States in these dikes, Diabase dikes that are relatively narrow and very long, and they're all oriented down here in the southeast. They're oriented, these Diabase dikes are oriented northwest to southeast, which is the opposite of the general strike of the rock layers here. The general strike of the rock layers here in the eastern United States are parallel to the Appalachian Mountains, because all that stuff was shoved up from the southeast into long mountain formations that ran from northeast to southwest. But the Diabase dikes are opposite. That's because they were the blowtorches that did the work of splitting up the Pangaea's supercontinent. Diabase is an mafic igneous intrusive rock. And as Rodinia began to split apart, these Diabase magma was squirted into cracks and split. That's what helped split the continent up and rifted it apart and formed an ocean. Rifting creates and enlarges oceans. Okay, rock buds, hope that was helpful to you. Thanks for watching, and you guys have a great day. This is your Rock Papa saying happy rock hunting. Pop out. Excuse me. Pop out.